Welcome to all of you. Now we discuss MCQ 2020 paper CC-12 semester 5 CBCS Mathematics Honors University of Calcutta Group Theory and Linear Algebra. Question paper 2020 paper CC-12 question 1a. Let G be a group and F maps from G to G be an automorphism such that fx equal to x to the power n, where n is a fixed integer, then what is correct? Correct option is 3. A to the power n minus 1 belongs to ZG for all a belongs to G. For details explanation, see question paper 2023 paper CC-12 question 1D. Next question. Let G be a cyclic group of order 2021. Then the number of automorphism defined on G is what? Correct option is 1932. Correct option 2. Now we know the following results. If G is an abelian group of order n, then the mapping F maps G to G defined by fx equal to x to the power m, x belongs to G, where GCD of m and n equal to 1, that is m and n prime to each other, is an automorphism. Here n is the order of the abelian group G, and this x to the power m is the power of x, this fx equal to x to the power m, and n and m prime to each other, then this F mapping G to G is an automorphism. If G is a finite cyclic group of order n, then the order of the group of automorphism of G is phi n, that is order of the automorphism G equal to phi n, where phi n denotes the number of integers less than n and prime to n, that is this phi is the Euler's phi function. If G be the finite cyclic group of order n, then the order of the group automorphism is phi n, Euler phi function. If n equal to p1 to the power k1, p2 to the power k2, pr to the power kr, and p1, p2, pr are all primes, k1, k2, kr are all integers and non-negative integers, prime factorization of n, this is the prime factorization of n, then Euler's phi function phi n is equals to n into bracket 1 minus 1 by p1 into bracket 1 minus 1 by p2, bracket goes into bracket 1 minus 1 by pr. Now 2021 equal to 43 into 47. So 43 and 47 are primes. So phi 2021 equal to 2021 into 1 minus 1 by 43 into bracket 1 minus 1 by 47 equal to 1932. So number of group automorphism is this phi n here 2021 phi 2021 equal to 1932. Hence the correct option is 2. Question C. The number of elements of order 7 in a group of order 28. Number of elements of order 7 in a group of order 28 is what? Let G be a group of order 28, since 7 divides the order of G, is the 7 is the order of an element, and G be a group of order 28, so obviously 7 divides 28, and 7 is prime, by Cauchy's theorem, G has a subgroup H of order 7. What is Cauchy's theorem? Let G be a finite group of order n such that n is divisible by a prime p, then G contains an element of order p and hence a subgroup of order p. Suppose there exist two distinct subgroups H and K of order 7. Then H intersection K equal to the singleton set E being the identity of the group G. Hence, order of HK equals to the order of H into order of K divided by order of H intersection K. So, order of H is 7, order of K is 7, and order of H intersection K is E, so order of H intersection K is 1, so 49. So, this order of HK is 49, which is greater than 28, the order of the group. So, it is a contradiction. Hence, H equal to K. So, G has only one subgroup H of order 7. Let A belongs to G be such that order of A equal to 7, whence H equal to the set generated by A, cyclic group generated by A, which implies that A belongs to H. Hence, every element of order 7 of G lies in H. Now, all non-identity elements of H are of order 7, and there are 6 such elements in H. Hence, G contains 6 elements of order 7. Notes that if H and K be two subgroups of a group G, then HK, this is the set of all those elements product H into K such that H belongs to H and K belongs to K, is a subgroup of G. If H and K are finite subgroups of a group G, then order of HK equal to order of H into order of K divided by order of H intersection K. Hence, G contains 6 elements of order 7. Correct option is 2. Question D. Order of the element, this order pair A, this cycle 1, 2, 3 belongs to K4 cross S3 is correct option is 6. Details answer given in the question paper 2023 CC-12 paper question 1B. Correct option is 4. Question E. If G be an infinite cyclic group, then automorphism Z is a group of order what? Correct option is 2. We have the theorem. If G is an infinite cyclic group, then automorphism G is a group of order 2. Clearly, G is isomorphic to Z plus, and Z is a set of all integers. So, it is sufficient to determine all automorphism of Z plus. Details answer C 2023 paper CC-12 question 1C. Correct option is 2. Question F. The orthogonal complement of W equal to the sets x, y, z, y order triplet belongs to R3 such that x plus y minus z equal to 0 and x minus 2y plus z equal to 0 in R3 is what? Correct option is 2. Now for this W, this x plus y minus z and x minus 2y plus z equal to 0. Adding, we get 2x minus y equal to 0 or y equal to 2x. Now x plus y minus z equal to 0. So put y equal to 2x here. So x plus 2x equal to z. So z equal to 3x. So for this rotated bracket x comma y comma z, we get x comma 2x comma 3x. This is equal to x common 1 comma 2 comma 3 for some scalar x. Hence W, this set equal to the linear span of this singleton set or triplet 1 comma 2 comma 3. This equals to a linear span of W, say W equal to this bracket 1 comma 2 comma 3 or triplet, this belongs to R3. Now for option 2, let S is the set is x comma y comma z belongs to R3 such that x plus 2y plus 3z equal to 0. Let alpha equals to bracket a comma b comma c belongs to S, and then a plus twice b plus c, because alpha belongs to S. So a equal to minus 2b minus 3c. Then alpha equal to this a minus 2b minus 3c and this b, this c. So b is equal to b, this order triplet minus 2 comma 1 comma 0 plus c, order triplet this into vector minus 3 comma 0 comma 1. This vector, this belongs to the linear span of this vector minus 2 comma 1 comma 0 and minus 3 comma 0 comma 1. So is a subset of this linear span of UV, where u equal to this and v equal to this. Also u comma v belongs to S. Then L of UV is a subset of S. Hence S equals to the linear span of UV. Now W dot U is W is equal to 1 comma 2 comma 3, this vector, this 1 comma 2 comma 3 dot u equal to minus 2 comma 1 comma 0. So this is equal to 0, and w comma v equal to also 0. Hence orthogonal complement of w, that is w perpendicular, equal to S. Hence the correct option is 2. Next question, G. Minimal polynomial of the matrix 5 minus 6 minus 6 minus 1 4 2 3 minus 6 minus 4 is what? Now the characteristic polynomial of the given matrix is this 5 lambda minus 6 minus 6 minus 1 4 minus lambda 2 3 minus 6 minus 4 minus lambda, this determinant equal to 0. Expanding and simplifying, we get lambda minus 2 whole square into lambda minus 1 equal to 0. So eigenvalues are 1 comma 2 comma 2. Let the characteristic polynomial be fx, this is equal to x minus 1 x minus 2 whole square. For this lambda, put lambda equal to x, so x minus 2 whole square into x minus 1, this characteristic polynomial. Obviously f of a, if we put matrix A in place of A, then obviously this polynomial, metric polynomial is this A minus I into A minus 2I whole square, this is equal to null matrix. Obviously this. The characteristic and minimal polynomials for the given matrix A have the same roots except for multiplicities, then the minimal polynomial must be either fx, this fx characteristic polynomial, or gx, where gx equals to x minus 1, x minus 2. Now, G equal to a minus I, identity matrix of order 3 into a minus 2i. Now, a minus I equal to this and a minus 2i equal to this matrix. And a minus I into a minus 2i equal to this null matrix this. So, this A this annihilates this polynomial Gx. Hence, no polynomial which annihilates, that is vanishes, A has smaller degree than G has. Hence, G, that is equals to x minus 1 into x minus 2, is the minimal polynomial of the matrix A. Hence, correct option is 2. Next, H. T be a linear operator on C3 defined by T of this vector x comma y comma z equal to 2x comma 0 comma x. Then the adjoint operator T star of T is given by this. By the definition, the inner product of T alpha comma beta equal to inner product of alpha comma T star beta for all alpha comma beta belongs to C3. Now, inner product of T alpha comma beta equal to this vector 2x comma 0 comma x comma this vector a comma b comma c. Let alpha equal to this, beta equal to this. So we can write 2ax plus cx, and we can write this inner product of x comma y comma z comma 2a plus c comma 0 comma 0. This is equal to inner product of alpha T star beta comma beta. Hence, T star beta equal to T star a comma b comma c. This equals to twice a plus c comma 0 0. Hence, T star x comma y comma z equal to this vector 2x plus y 2x plus z comma 0 comma 0, where x comma y comma z belongs to C3. So correct option is 1. Question I. Signature of the quadratic form 5x square plus y square plus 10z square minus 4yz minus 10zx is what? The associated symmetric matrix A for the given quadratic form polynomial A equal to 5 0 minus 5 0 1 minus 2 minus 5 minus 2 10. Apply congruence relations on a to reduce its normal form. A equal to this, first apply R3 plus R1, correspondingly C3 plus C1, then R1 by root 5, C1 by root 5, R3 plus 2 R2, C3 plus 2 C2, and then we get this normal form 1 0 0 0 1 0 0 0 1 is B.Sc. Thus, B is fully reduced normal form of A. Hence, the rank of A, and this is the non-zero number of non-zero rows in B, is equal to 3. This is smaller. Index of A equal to 3, M, number of positive ones is 3. So, signature of A is equal to 2M minus R, 2 into 3 minus 3, this is equal to 3 also. It's the number of positive ones minus number of negative ones in B. Hence, the signature of the matrix A is 3. Question J. If B is the set V1, V2, V3 is an ordered basis of for C3 defined by V1 equal to 1, 0, minus 1, V2 equal to 1, 1, 1, V3 equal to 2, 2, 0. These vectors V1, V2, V3. Then the dual basis F1, F2, F3 of B is given by what? correct option is 2. Take the linear functionals, the set f1, f2, f3 of B, that standard forms. f1 x, y, z, this is equal to a1 x plus a2 y plus a3 z. f2 x, y, z equal to b1 x plus b2 y plus b3 z. f3 x, y, z equal to c1 x plus c2 y plus c3 z. Now f1 v1 equal to 1, f2 v2 equal to 0, f1 v3 equal to 0. f2 v1 equal to 0, f2 v2 equal to 1, f2 v3 equal to 0, f3 v1 equal to 0, f3 v2 equal to 0, f3 v3 equal to 1. Actually, we use here formula fi vj equal to 1 if I equal to j, and fi vj equal to 0 if I not equal to j. So we can write this. Then f1 v1 equal to 1, so 1 equal to f1 v1 equal to f1 v1 is this, given the v1 vector is this 1 0 minus 1. So 1 0 minus 1. So from this f1 a1 x plus a2 y plus a3 z. So this a1 into 1, a2 into 0 plus a3 into minus 1. And f2 v2 this is equal to 0. So f1 into 1 value of v2. So this, and f1 v3 equal to 0. So f1 2 0 this is equal to this. And solving this, we get this a1 equal to 1 plus a3, and a1 equal to from this minus a2, thus a3 equal to 0. Hence a1 equal to 1, a2 equal to minus 1, a3 equal to 0. So we put this a1 is the a1 equal to 1, a3 equal to 0. So this x minus y, f1 is f1 x y z equal to x minus y. Similarly, we can find f2 and f3. Here f1 is x minus y. Actually only option is 2 is correct for f1 equal to x minus y. Hence we can choose, and the correct option is 2. Thank you for watching this video.